Hi everybody, welcome back. So now we are going to officially get into trigonometric functions. With the angles, just as we take angles by themselves, those aren't periodic. We want something to use to model the periodicity of certain things. And that's where these trigonometric functions come in. So essentially with an angle, there are several functions that are associated with that angle, and these actually are numbers associated with that angle. And the two most common numbers or functions is called the cosine and sine of that angle. And it's probably best to describe what these are using the unit circle. So remember, the unit circle is just, it's given by this equation, x squared plus y squared equals 1. It's basically the set of all points on the xy plane at a distance of exactly 1 from the origin. Okay, so if we take an angle between 0 and 360 degrees, that corresponds to a certain line coming out of the origin, where theta is the angle between that line and the positive x-axis, and that line intersects a unique point on the unit circle. That point has an x-coordinate and a y-coordinate. We call the x-coordinate the cosine of theta, and the y-coordinate the sine of theta. And then after we have that, we define about 4 extra functions. We define the tangent of theta as the sine of theta divided by cosine of theta. And what that amounts to is that's the slope of this line, right? Because it turns out the sine, this is the y-coordinate, so in this case the y would be this vertical distance. The cosine is the x-coordinate, so the cosine of theta represents this distance, this horizontal distance. So the rise divided by the run is the slope, and that's the tangent of theta. Then we can take the reciprocals. If we take the reciprocal of the tangent, we get something called the cotangent of theta. The reciprocal of the cosine of theta is called the secant of theta, and the reciprocal of the sine of theta is called the cosecant of theta. Now, obviously, if the denominator is ever 0, that these things are undefined, but we'll see that obviously for cosine theta and sine theta, these are always defined, because you always get, no matter what angle you take, you always get a point on the unit circle. And if you take this theta and add 1 revolution to it, the value of theta would change, but the point would be the same. So the cosine and sine would be unchanged when you replace theta with when you add 1 or more revolutions to theta in either direction. Okay, so, and we can see there are some other things. We can see that the cosine and sine of an angle have to be between -1 and 1, and there are a lot of other properties, but we'll just do some simple examples for now. So here, for 0, so when the angle is 0, that corresponds to this point, and this is the point 1, 0. So this tells us that the cosine of 0 is 1, and the sine of 0 is 0. Okay, and right here the angles both in the radians and degrees, and of course in 0 they're the same. Okay, the tangent of 0, that would be 0 divided by 1, which is just 0. The cotangent would be 1 divided by 0, but that's undefined, so we'll make a little slash there because it's undefined. Remember, you can't divide by 0. The secant would be 1 over the cosine, well, the reciprocal of 1 is just 1, and the cosecant of 0 would just be 1 over 0, but that's undefined as well. Okay. All right, let's go to pi over 2, or 90 degrees. That is going to correspond to this point, and the coordinate of this point is 0, 1, so everything is changed. Everything is interchanged. The cosine is 0, and the sine is 1. And now the tangent is undefined, because it's 1 divided by 0, and 0 divided by 1 is the cotangent, and the secant is 1 over 0, that's undefined, and the cosecant is 1 over 1, which is 1. For 180 degrees, that takes us over here, And the the coordinates are negative 1, 0. So the cosine would be negative 1. The sine is 0. 0 divided by negative 1 is 0. Negative 1 divided by 0 is undefined. And the secant, that's 1 over negative 1. 1 over negative 1 is just negative 1. And 1 over 0 is undefined. And then 270 degrees, or 3 pi over 2, 270 takes us all the way down here to this point. This is 0, negative 1. And so the cosine is 0. The y-coordinate is negative 1. The sine is negative 1. Negative 1 divided by 0 is undefined. 0 divided by negative 1 is 0. 1 over 0 is undefined. And 1 over negative 1 is negative 1. Okay. And then 2 pi is the same thing as 360 degrees, but that, of course, corresponds to the same point, right here. So all the values for 0 are going to be the same as the values for 2 pi. So this would be 1, 0, 0, undefined, 1, undefined. Okay. All right. Now, what about the next three, these other angles? Pi over 445, 30, and 60 degrees. Okay. Well, we have to do a little bit of algebra to do this, but it's not too bad. Okay. Because if we go to page 2 here, work this out. I've basically zoomed in. Here's our unit circle, and here's the point, and here's the angle, 45 degrees. And as before, we can form a right triangle from this point by just drawing this vertical distance and the horizontal distance. So this of course is the this distance would be the sine of 45, and this would be the cosine of 45. But we can see that in this case they're both equal, because we know about we know a little bit about geometry. We know that if these two angles are equal, then these sides are equal. Okay, so let's call these sides, give that a name x. And then by the Pythagorean theorem, we get x squared plus x squared equals 1 squared. Okay, and this is 2x squared equals 1. We can divide both sides by 2, and then take the square root of both sides. Now normally we take plus or minus a square root, but it's clear that this point is in the first quadrant, so everything has to be positive in the first quadrant. So we're just going to leave it here, and we can rationalize this. This is the same thing as 1 over square root 2, and we can rationalize it. And so x is going to be square root 2 over 2. Okay, so this represents the x and y coordinate of this point. Okay, so that's the sine and cosine are equal when theta is 45 degrees. Okay, and then this and this are the same, so this divided by this is going to be 1. The reciprocal of 1 is 1. Okay, and 1 over the cosine is 2 over square root 2. Okay, and actually that simplifies to the square root of 2 in this case. And then you can check that the reciprocal, of course, since the sine and cosine are the same, the secant and the cosecant won't be the same. So this will be square root 2 as well. We're not going to worry right now about using our calculators right now. We're just going to give the exact values in terms of square roots. Now, what about these other two angles, 30 degrees and 60 degrees? Well, if we do this, let's do this again, draw the similar picture. We have a triangle where this angle is 30 degrees. Now, obviously, these two are are going to be different. Okay, if let's call this x, and we can call this y. Okay, we get something different. So how can we do this? Well, we can basically view this triangle as half of a bigger triangle. If we take an equilateral triangle, where each side has length 1, and let's say here's 30 degrees, here's 60 degrees, this is 60, and this is 30. So in an equilateral triangle, all the angles are equal to 60 degrees because and the sides are all, in this case, equal to 1. We can see that this distance has to be 1/2. Okay, because it's 1/2 of this, and then if we call this side x, we have this. Again, we have a right triangle right here, so we get x squared plus 1/2 squared is equal to 1 squared. Again, by the Pythagorean theorem. And this says x squared plus 1/4 equals 1. You can subtract 1/4 from both sides. And so x squared is 3/2, and then x is going to be the square root of 3/2, okay, which we can again rationalize. Actually, I'm sorry. This should be 3/4. Sorry, this is 3/4. And now, this is 3/4, and then we can rationalize this to square root 3/2. Okay, so it's 3/4, right? Okay, so that's what x is. So then, if we take this angle and this triangle right here and just put it on its side, so it's like this. Here's 30 degrees, and here's our point, and now we know that this is 1/2, and that this is square root 3/2. So the coordinate of this point is square root 3/2, comma, 1/2. Okay, and so that's going to be the sine and the cosine and sine of 30 degrees. Okay, so we can say this is square root 3 divided by 2. And this is 1/2, and this divided by this, we can, this is 1/2 divided by square root 3/2. If you wanted to simplify this, this is take the reciprocal, so this would be 1 over square root 3. And if we rationalize this, this will be square root, we can rationalize it and get square root 3/3. Or we can just write this as 1 over square root 3. Maybe we can, well, I guess we'll write it like this. So this will be square root 3/3. And the reciprocal of this will be square root 3. And then the secant is the reciprocal of the cosine, so this will be 2 over square root 3. Which, after we rationalize it, it's 2 square root 3/3. So I guess we can leave it like that. Yeah, so, and you can, if we take the reciprocal of the sine, that's easy. The reciprocal of 1/2 is just 2. Okay. All right, now let's do this for 60 degrees. For 60 degrees, we can basically use this. Notice that this triangle is basically the same thing as this triangle. It's just on a different space. So we've already we can put this, just transfer this to here, and we know that this distance is 1/2. We know that this distance is square root 3/2, right? So this point is 1/2 comma square root 3/2. And then, so that means this will be the cosine of 60, this will be the sine of 60. Notice that these are just interchanged here. And then the tangent is the is this divided by this. That's square root 3. Take the reciprocal of that, we get square root 3 over 3. Take the reciprocal of the cosine is 2. Take the reciprocal of root 3 over 2. That is what we had, square root 2 square root 3 over 3. Okay. Okay. The main thing about this is that once you know the sine and cosine, you can compute all the other things. So it's important that you get the sine and cosine right. So these, unfortunately, yes, these values are the things you definitely have to memorize, especially these last 3 angles. These first ones aren't too bad if you just draw the picture of the unit circle, and you can easily tell what the coordinates of these quadrant points are. But these are the ones you want to keep in mind. One way to memorize this is that in these 3 angles, the denominator is always 2. And on the top you have, we can call this the square root of 1, square root of 2, square root of 3. Okay, so that's one way of memorizing that. Okay, so we'll do calculate some more sines and cosines in the next video.